Okay, now that we've done that, my name is Richard Milhouse Nixon. And you can't prove it, that it's not. All right, so let's go here. They're just asking the properties of metals, nonmetals, and metalloids. Metals conduct electricity. They are malleable. They are shiny. This just means bendable, remember? And remember that copper wires are what conducts electricity. They are bendable. They are shiny. They react with acid. So this is metal. And all metals have a positive oxidation number. Now, we don't know what it is exactly. I mean, it could be +1, +2, +3, +4, +5, whatever. We just know that it's positive, right? Right. Okay. Unknown B, it conducts electricity like a metal, but it's brittle like a non-metal, but it's shiny like a metal, but it doesn't react with acid. So this is a metalloid. And metalloids can be plus or minus because they're along this stair step. So it could be +3, it could be -3, it could be any host of things. And so this is the last choice is non-metal, and they are negative for the most part. Okay, so I said to change this to number 18. 118 would be right here. 109, 110, 11, 12, 13, 14, 15, 16, 17, 18. So, would it conduct electricity? Well, neon conducts electricity. That's how we make light. So I'm going to say yes. So does argon, krypton, and xenon, by the way. Malleable or brittle? Well, it's a gas, so I guess if you froze it down to where it was a solid, it would be brittle. Appearance? Well, it's a gas. Reacts with acid? No, it doesn't react with acid. It's totally unreactive because it's a noble gas. Non-metal. And its oxidation number is 0. There is no oxidation number for noble gases. Okay. Okay. Now this part was befuddling some of you, so let's sort this out. Sodium phosphate. First of all, sodium is not S. Sodium is Na. So this is Na. And get in the habit, when you're writing a formula, immediately think, I need to write the charges over this. So this is sodium and phosphate. Phosphate's on the back. If it had said phosphide, it would have meant phosphorus. But it says phosphate, and that's something that's on the back. Phosphate, PO4, and it's -3. PO4, and it is -3. And then I crisscross. All ionic stuff you have to crisscross. They're not saying, you can't say, it like in a covalent where it says dioxide, it tells you exactly how many atoms I have of stuff. This doesn't. So I need to know how many atoms I have. So I have 3 crisscross, the 1 is here, right? Right. Okay. Cobalt 2 chlorate. So I have cobalt. They've told me it's charged +2 by indicating that with a 2 in the parentheses here. So I'm going to put a little +2 above it. And then chlorate. Chlorate, ATE, it's on the back. ClO3, and it's -1. ClO3, and it is -1. So if I crisscross, that 2 comes down here. Done with that. Calcium fluoride. Oh, stuff that's all on the front. So calcium is right here. It's +2. Calcium +2. And fluoride is -1. It's right here. So if I crisscross, the 2 comes down here to the fluorine. CaF2. Lead-3 nitrate. Pb +3. Nitrate, again, we got to go to the back. Nitrate, NO3 -1. NO3 -1. So 3 comes down here, 1 goes down here, don't need to write it. Make sure that you put parentheses around every polyatomic. All a polyatomic is if you have more than 2 elements in a compound. 1, 2, 3. You can tell by the capital letters. 1, 2, 3. I have 3 elements. Somewhere there's a common ion. PO4, you're going to get used to seeing them. 1, 2, 3. 3 elements, calcium, chlorine, and oxygen. This has 2. This is binary. So no parentheses necessary. Lead nitrate, PbNO, 1, 2, 3. So let's look down here. 1, 2. So this has 2 things. This has 1, 2, 3. Obviously a polyatomic. 1, 2, 3, 4. 2 polyatomics. 1, 2 is binary. 1, 2 binary. Okay. Anyway, let's not get off track. Aluminum. Sorry, Haley. Sorry. Phosphide. So this is stuff that's on the front. Phosphide is just a phosphorus, and it is -3. Phosphorus, and it is -3. And I'm still going to have you crisscrossing, and I'll tell you if they cancel out. If they cancel out and they want the answer in this form, I'm going to tell you that. I'm going to say, hey, cancel them. Right now, I like using them because if you have to reverse crisscross to figure out like this lead, if this had been 3 and that had been 3, we would have crisscrossed and they would have eliminated each other and it just would have been PbNO3. From that, you would have thought the lead was charge 1, +1, just because those charges canceled. So I like doing it this way, actually crisscrossing and have the numbers down there. Okay, so yeah, we crisscross those. All right, naming. When you're naming ionic compounds, and these are all ionic compounds, you're naming the first thing and adding an IDE ending to the last thing. So this just becomes magnesium bromide, right? And the only time you need to add a Roman numeral in the middle is if you're dealing with things that are transition metals or that act like transition metals. So these things, remember, they act like transition metals. And remember that these things do not. These things have a charge. Oh, and by the way, that charge is right on the back. Silver, zinc, and mercury. They tell you what the charges are. So magnesium bromide, magnesium, not a transition metal. So no need for Roman numerals. Lithium, not a transition metal. Lithium and ClO4. ClO4 is right there. It is a perchlorate. So I have lithium perchlorate. Sorry, Haley, if I'm talking too much. And then here, it's just a name. So the rules are we add an IDE ending if it's a binary compound. So if it's 2 elements, IDE ending. If it's more than 2, then you have to name the polyatomics. This is a perchlorate. This is an ammonium. This is a phosphate. Phosphite, sorry, PO3. Phosphite. So you have to name those things. So this is ammonium. Phosphite. This is going to have an IDE ending because it's binary. It's just 2 things. So it's barium oxide. And what is the charge on the sulfur? Well, here, where did the charge end up? It ended up as the subscript for the chlorate. And here, where did it end up? It ended up as the subscript for the nitrate. So guess what? This ends up as the subscript for the oxygen. So this is 10,2 oxide. It was the only one we had where we had a transition metal, but that should be the first question you ask. If they show you something and ask you to name it, first thing I would ask myself is this a metal or non-metal? Second thing I would ask myself is, if it's a metal, is it a transition metal? Does that make sense? I hope so. All right. So that is page 1 and 2 in the books. Page 3. Okay, I'm gonna, what are we at? We're at 10 minutes. Oh, somebody's texting me a lot. I'm going to stop the video and start it again here momentarily.